We are taking MCQ on microprocessor, multiple choice questions. What is the vectored address of RST5? So these are the address RST0 till RST7, and these are all these software interrupts. The answer is C, and I'll tell you how to find this, because there is a proper formula here. The vectored address of RST from 0 to 7, that is, you can call it as RST n can be from 0 to 7. It will be n into 8. That is, if RST5 you have to calculate, in place of n put 5 8s are 40, and this is the decimal form. So you have to change it into hexadecimal. That will be 28 in hexadecimal. This is how you find out. Which of the following is true about stack pointer? Okay. The answer here is the stack pointer contains the address of the top of the stack memory. So whenever you are doing some programming, etc., there will be a RAM stack in the RAM. So that will be allocated to you. So there will be a stack pointer, there will be a stack initialization. So the stack pointer is a 16-bit register that will store the data temporarily. For example, if you are running certain program and there is a subroutine. So when you go to the subroutine, you have to have the next address, instruction address to be placed somewhere, so that you can recall it when you come back to the main program. And that is only possible when you have stack-like operation. The stack pointer is initialized before the stack operation and store the data not permanently, only temporarily, and stack pointer is initialized before the stack operation. The stack pointer is 16-bit, so it has to be initialized before stack operation, not after the stack operation. Otherwise, it may not have any use. How many address lines are required to connect a 4 KB RAM to a microprocessor? So always remember, the memory is 2 to the power 2 raised n. So we have 4 KB. So 1 K is what in memory terms? 1024. So 1024 is nothing but 2 to the power 10, and 4 is 2 to the power 2. So 2 to the power 12, which is going to be 2 to the power 10. This is 2 to the power 2. So it is going to be 2 to the power 12. 4096. So these are 12 address lines. Which of the following is true about move A, B instruction? Okay. See, move, what all is there? First, let me tell you one by one. First is, it doesn't affect the flag register. This is your answer. It doesn't affect the flag register, because move is doing what? If you have a location, one source, one destination, from source it goes to the destination. The content is only copied. It is only copied. So there will be no change in the flag register. It is not a 2-byte instruction, but it is because move is 1-byte instruction. It means move the content of register A to B. No, it means moving the content from register B to A, not A to B. That is why this is also wrong. It uses immediate addressing mode? No. It uses the register addressing mode. So the only answer is C. All others are incorrect. Which of the following is false about LDA instruction? See, LDA is load accumulator direct. Load accumulator direct. Right? So this is the full form. Now this is a direct addressing mode instruction. So it uses indirect addressing mode. That is going to be false, because LDA is a direct addressing mode, because after that the address is directly given in the instruction. LDA 2000H. So 2000 is already given. It is direct addressing mode. And then it is actually 3-byte instruction. That is correct. It has or it uses 13 T states. That is also correct. And it doesn't affect any flags. That is also very true. So only the false option is it uses indirect, because it actually uses the direct addressing mode, right? Load accumulator direct means you are loading accumulator directly to this. Wherever this address is pointing, the data on this address will be loaded to the accumulator. Which of the following is true about STA instruction? So STA instruction is store accumulator direct. The answer is it is a 3-byte instruction. Store accumulator direct. It is a 3-byte instruction. That is correct. Now what all are incorrect? It uses immediate addressing mode. No, it uses direct addressing mode, because the address is directly given after STA. 3-byte, yes. It requires 3 machine cycles. No, it uses 4 machine cycles. Accumulator is loaded with the content of memory. No. And ST instruction memory is loaded with the content of the accumulator, not the content of the memory. Okay. This is also incorrect, because STA instruction memory is loaded with the content of the accumulator. DAA instruction is used to perform which type of addition? So DAA is simply decimal adjust accumulator. So the answer here is it's A, BCD addition. This DAA instruction is used to perform the binary coded decimal addition, and the DAA instruction changes the binary values of the contents of the accumulator to what? To the binary coded decimal. You see also in the example, I've tried to show it. Okay, you can just go through it, but the answer here is A, BCD addition. What does a loader do in a microprocessor? What is the loader doing in the microprocessor? Loader does the same thing, because microprocessor or any computing device, it only understands zeros and one. That is binary. So loader does what? It first converts the hexadecimal code to the binary form and then loads it to the memory. Let me tell you again. Loader task is to convert hexadecimal code, that is the H form, into the binary 01 form, and then loads it to the memory. So the answer is converts hexadecimal code to binary. Suppose registers A and B contains 50H and 40H respectively. After instruction move AB, what will be the contents of register A and B? The move is what? A comma B. So the content of B will be transferred to the content of A from source to destination. But the A will have the content of B, but B won't change. B, until you replace it, if A is having 50, B is having 40, when you transfer, when you move, now A will have 40, B will itself have 40, because it was having 40 until it is not being replaced. So the answer will be 40, 40. So that will be A. So A and B both will contain 40, 40H. For how many times per instruction the content of the program counter is placed on the address bus? Now this is a very tricky question, because the answer we cannot give. It depends on the length of the instruction. Whenever we decode an opcode, the microprocessor understands then what is the length of the instruction. 1 byte, 2 byte, 3 byte, what have to be performed, how many fetch, how many T state, how many operation, how many instruction cycles. So the content of the program counter is placed on the address bus. It may be as many times as the length of the instruction. So we cannot tell it right now. It depends totally on the length of the instruction. Conditional instructions are independent of which of the following flag? So these are all flag. You know these all flag we have already discussed. So the answer here is auxiliary carry. Because conditional instructions, they are branching instructions. Branching, that is jump not zero. For example, if you know something about C, C++, Java, if else, while, do while, all these are branching instructions. So here which we are talking about, the conditional instructions, they are branching instructions. The looping may go, or you may go somewhere else, like that. So in this group, the program control is transferred from one location to another conditionally. So they depend on the status of the flag affected for previous ALU operations, except the what? Auxiliary carry. Which of the following is not correct about halt instruction? Now the name itself is halt, that is stopping. It is already saying stop. So the answer, what is the answer? Not correct about halt. What is not correct? The answer is B. It is used to start the execution of the program. Actually, it is not correct, because halt means stopping. Halt is a machine control statement. Internally, what is being done is the PC is disconnected from the address bus, for example, so the next fetch won't be possible. So it is used mainly to stop the execution of the program. Okay, so it does not affect the content of the register and flags. Once the processor is halted, it can be brought to the normal mode only by the resetting the processor. So halt is used as a last instruction in every assembly language program. Halt, the instruction stops the processor. Okay. So the 8085 repeats the fetch, decode, execution cycle until it is deliberately stopped, which is done by halt. HLT is the option. When data required for instruction is present inside the register of a microprocessor, then which of the following addressing mode is used? The question is also answering the actually option, because register addressing mode is used when the data is present inside the register of the microprocessor. For example, move B, C. B and C are the registers of the microprocessor. So the answer itself is the register. There are different types of addressing mode: immediate, direct, register, indirect, and implied. Which of the following interfacing IC, integrated circuit, is a DMA controller? DMA is direct memory access. Okay, the answer is, see, let me tell you, because it is very specific, it doesn't have any explanation like that. So the 825737 is the answer. 8155 is a multi-purpose programmable input-output device. 825354 is a programmable counter. 8279 is a keyboard display controller. And this 825737 is a DMA controller. So the answer will be A here. Which of the following is a two-word instruction set? Two-word instruction set. Answer is C. IN01H. The first one LDA 2500H and these JMP 2085, because the direct address is given, it is a three-word instruction. All the memory address is given. That is why it is a three-word instruction. Move A, B is a one-word instruction. No, there is no data, only A and B is given. So IN01H, this is a two-word instruction. What is this? The first byte is specifying the opcode, which is IN here, and the second byte, which is 01, it will specify the operand. Which of the following is a register indirect addressing mode instruction set? So the answer is D here. Actually, it's LDAX. LDAX. Now this the first one, if you see, LDA 2700, let me tell you one by one. This is a direct addressing mode instruction because 2700 is already given. ADI 36H, because 36 is the data, is an immediate addressing mode instruction. DIA is an implicit addressing mode because nothing is given. And LDAX, B is a register indirect addressing mode instruction. Which of the following is true about SPHL instruction? Now SPHL, SP is for stack pointer, HL is for HL general purpose register. The answer is content of HL pair is moved to SP. Now if you remember B, C, D, E, HL, there were these register pairs we talked about. So SPHL is basically a 1 byte instruction. It uses register addressing mode. It is using register addressing mode. It requires 6 T states, and it is a 3 byte, no, it is 1 byte, and 6 T states it use. It means moving the contents of HL pair to the SP, that is the stack pointer. HL to stack pointer. Okay. So this is all about these questions. Thank you so much.